I'm Jeroen van May, and welcome to my lecture series on computer and network security. In the previous video, I talked about authentication and authorization and how they form the basis of access control. In this video, I'll go into more detail to network access control and specifically the IEEE 802.1x and EAP standards. And here you see a generic depiction of the different actors involved in network access control. There are basically three involved actors. The first one is the access requester, AR, also referred to as a supplicant. This could be a user with a smartphone or laptop or workstation, but could also be a printer or any other IP-based device. Second is the policy server. Based on the information provided by the supplicant, the policy server will determine what access should be granted to this supplicant. The policy server often relies on backend systems such as antivirus, patch management, or a user directory to help determine the host conditions. Finally, the third involved party is the network access server, or NAS. The NAS functions as an access control point for users in remote locations, connecting to the enterprise's internal network. It will contain an authentication server that determines whether or not a user's identity can be verified, but can also contain other types of servers such as a virtual LAN server or a DHCP server, and so on. And the Extensible Authentication Protocol, or EAP, and IEEE 802.1x standards provide a framework for network access and authentication protocols. EAP is standardized as an IETF RFC with number 3748. Basically, it provides a set of protocol messages that can encapsulate various authentication methods to be used between a supplicant and an authentication server. As such, it enables authentication over a network between hosts in the network. It can also operate over a variety of network and link layer facilities and technologies, such as the point-to-point links, local area networks based on Ethernet, wireless LAN, so the Wi-Fi standards, and so on. As I mentioned, EAP provides an abstraction between various authentication methods and different network technologies. Here you can see some of the most important authentication methods that can be used together with EAP. The first one is EAP TLS. TLS stands for Transport Layer Security. It's something I will talk about in a future lecture. This authentication method basically uses the handshake protocol, which is used for authentication of TLS, not the encryption protocol. Specifically, the supplicant and authentication server will exchange public key certificates. After exchanging these certificates, the supplicant can use the certified public key of the authentication server to encrypt a randomly generated master key and send it to the authentication server. Subsequently, this master key can be used to derive session keys and set up secure communication. EAP TTLS is similar, except here it's assumed only the server has a public key certificate available. The server will send the certificate to the client will use it to generate a master key and securely send it towards the server, and after that another EAP authentication method will be used to authenticate the client to the server. In GPSK, pre-shared keys are used for mutual authentication. So using this pre-shared key, private session keys are derived and symmetric encryption is used to authenticate client and server. Finally, in the last method, EAP IKE version 2 is based on Internet Key Exchange, which is part of the IPsec protocol suite, which I will talk about in a later video of this lecture. And here you can see a typical arrangement in which EAP is used. It involves three entities. The first one is the EAP peer, which is also referred to as a supplicant, so it is the entity that is attempting to access the network. The second one is the EAP authenticator. The authenticator is, for example, an access point or a network authentication server that requires authentication of the supplicant before granting access to the network. Finally, the authentication server is a server or computer that negotiates the use of specific EAP method with the peer. It validates the credentials and authorizes access to the network. Typically, these authentication servers run the remote authentication dial-in user service or RADIUS. The authentication server functions as a back-end server that can authenticate supplicants as a service for different EAP authenticators. The authenticators then make the decision of whether to grant access or not based on the provided authentication credentials. An IEEE 802.1x is an IEEE standard to enable network access control in IEEE-based local area networks, such as, for example, Ethernet and Wi-Fi networks. And it's based on the concept of port-based network access control. This means that it uses a concept of controlled and uncontrolled ports. These ports are logical entities defined by the authenticator and refer to physical network connections. Each logical port is mapped onto one of these physical connections. An uncontrolled port allows exchange of data between the supplicant and the authentication server regardless of the authenticated state. This means that control messages and messages of the authentication exchange, such as EAP protocol messages, are always allowed into the network by the network access point. But only once the authenticator has authenticated the supplicant, the control ports are opened, allowing exchange of actual data traffic between the external supplicant and the internal system or network. An essential part of 802.1x and EAP is the EAP over LAN or EAPOL protocol, which enables the message exchange between a supplicant, an authenticator, and an authentication server. When a new supplicant or peer joins the network, it is not aware of whether or not there are authenticators present that require authentication. As such, the supplicant will start by multicasting an EAPOL start message. This message is multicast to a predefined IP address, and authenticators will be subscribed to this multicast address. As such, if such a message is received by an authenticator, they know a new potential supplicant has joined the network. They will respond with an identity request message. The peer will then reply with identity information, which will be intercepted by the authentication server. And at this point, the authentication process is started. The authentication server will then send one or more authentication requests. To each of these, the supplicant needs to respond with a successful authentication response. If all authentication requests are successfully answered, the supplicant has successfully authenticated and is notified of this by the authentication server. After this, the control ports can be opened by the authenticator so that the supplicant can start using resources in the network. At the end, a log-off message is transmitted. This ends the video on EAP and 802.1x. In the next video, I will talk about another method used in network access control, namely firewalls.